Nuclear reactions produce a considerable amount of energy. So it makes sense that if the reaction products could be contained, well, then they can be utilized for various types of work. For example, heat energy is a product of nuclear reactions. The heat energy can be directed towards a water source. When the heat energy comes into contact with the water is going to boil and produce steam. The steam can be directed and used for mechanical work to drive a turbine. The turning of the turbine can produce electricity. Nuclear reactors allow for the production of a cleaner energy type, unlike fossil fuel sources such as oil, coal, and natural gas. Nuclear power is particularly suitable for vessels which need to be at sea for extended periods of time. What is great is that they can be out in the sea without having to make frequent stops to refuel. Additionally, nuclear power is used to yield powerful submarine propulsion. Over 140 ships are powered by more than 180 small nuclear reactors. Most of these are submarines, but other ships that serve as icebreakers for aircraft carriers also utilize nuclear power. Up until this point, we have discussed chemistry that occurs between valence electrons transferring, as they do for ionic bonds, or valence electrons being shared, as they do during covalent bonding. Despite the differences in these bonding mechanisms, the nuclei have remained unchanged. Nuclear chemistry is the branch of chemistry that involves the breakdown or disintegration of an atom's nucleus. Obviously, if the nucleus is changing, then the reaction products will not contain the same elements as the original reactants. When nuclei spontaneously disintegrate, there are high energy emissions. The products that form and some of the initial reactants are considered to be radioactive. When collisions occur between the nuclear components, there will be some kind of result from the impact, which could be a photon emission or even an explosion. Of course, it all comes down to the amount of energy that's involved. The most basic nuclear particles are protons and neutrons. Protons have a positive 1 charge, and neutrons lack a charge. Neutrons have a little bit more mass than protons do. In atomic mass units, protons are 1.0072765 atomic mass units, while neutrons are 1.00866649 atomic mass units. So as you can see, the neutrons do in fact have just a slightly more nuclear mass.